So let's write down a differential equation. The derivative of y with respect to x is equal to 4y over x. And what we'll see in this video is the solution to a differential equation isn't a value or a set of values. It's a function or a set of functions. But before we go about actually trying to solve this or figure out all of the solutions, let's test whether certain equations, certain functions are solutions to this differential equation. So for example, if I have y is equal to 4x, is this a solution to this differential equation? Pause the video and see if you can figure it out. Well, to see if this is a solution, what we have to do is figure out the derivative of y with respect to x and see is that truly equal to 4 times y over x. And I'm going to try to express everything in terms of x to see if I really have an equality there. So first, let's figure out the derivative of y with respect to x. Well, that's just going to be equal to 4. We've seen that many times before. And so what we need to test is 4, the derivative of y with respect to x, equal to 4 times, I could write y, but instead of y, let's write 4x. I'm going to put everything in terms of x. So y is equal to 4x. So instead of 4y, I could write 4 times 4x. All of that over x. Is this true? Well, that x cancels with that, and I'm going to get 4 is equal to 16, which it clearly is not. And so this is not a solution. Not a solution to our differential equation. Let's look at another equation. What about y is equal to x to the 4th power? Pause this video and see if this is a solution to our original differential equation. Well, we're going to do the same thing. What's the derivative of y with respect to x? This is equal to, just using the power rule, 4x to the 3rd power. And so what we have to test is 4x to the 3rd power, that's the derivative of y with respect to x, equal to 4 times y. Instead of writing a y, I'm going to write it all in terms of x. So is that equal to 4 times x to the 4th, because x to the 4th is the same thing as y, divided by x. And so let's see, x to the 4th divided by x, that is going to be x to the 3rd. And so you will indeed get 4x to the 3rd is equal to 4x to the 3rd. So check. This is a solution. So is a solution. It's not necessarily the only solution, but it is a solution to that differential equation. Let's look at another differential equation. Let's say that I had, and I'm going to write it with different notation, f prime of x is equal to f of x minus x. And the first function that I want to test, let's say I have f of x is equal to 2x. Is this a solution to this differential equation? Pause the video again and see if you can figure it out. Well, to figure that out, you have to say, well, what is f prime of x? F prime of x is just going to be equal to 2. And then test the equality. Is f prime of x equal to f of x, which is 2x, minus x? And so let's see, we are going to get 2 is equal to x. So you might be tempted to say, oh, hey, I just solved for x or something like that. But this would tell you that this is not a solution because this needs to be true for any x that is in the domain of this function. And so this is, I'll just put an x there, or I'll put an incorrect there to say not a solution. Just to be clear again, this needs, in order for a function to be a solution of this differential equation, it needs to work for any x that you can put into the function. Let's look at another one. Let's say that we have f of x is equal to x plus 1. Pause the video and see, is this a solution to our differential equation? Well, same drill. F prime of x is going to be equal to 1. And so we have to see, is f prime of x, which is equal to 1, is it equal to f of x, which is x plus 1, minus x? And so here, you see no matter what x is, this equation is going to be true. So this is a solution. Is a solution. Let's do a few more of these. Let me scroll down a little bit so I have a little bit more space, but make sure we see our original differential equation. Let's test whether, I'm going to do it in a red color. Let's test whether f of x equals e to the x plus 1 is a solution to this differential equation. Pause the video again and see if you can figure it out. All right, well, let's figure out the derivative here. F prime of x is going to be equal to derivative of e to the x with respect to x is e to the x, which I always find amazing. And then plus 1, and the derivative of this with respect to x is just 0. And then let's substitute this into our original differential equation. So f prime of x is e to the x plus 1. Is that equal to f of x, which is e to the x plus 1 minus x minus x? And if that x cancels out with that x, it is indeed, they are indeed equal. So this is also a solution. So this is a solution. And we're done.